Welcome back, everyone. We are now going to be starting with section 6.6, which deals with reaction mechanisms. What a reaction mechanism is like a step-by-step recipe, if you will, on how a reaction happens. Now, in the last lesson, we used A plus B arrow C plus D, right? Like we would do A plus B arrow C plus D. Well, you know what? Very rarely do things happen in one step. In fact, it's very uncommon. All right. So when we talk about a reaction mechanism, we're talking about the actual step-by-step way of doing things. And something like this would be your net reaction. Okay. So what is a reaction mechanism? It's a series of elementary steps. And what an elementary step is like your bullets, like number 1, add this plus this. Number 2, add this plus that. So that's what an elementary step is. It is a step involving 1 or 2 or at most probably 3 things colliding. Because the reality is it's really hard for more than 3 things to collide at one time in the proper orientation with the appropriate amount of kinetic energy. Okay, so we're really kind of distilling reactions down to a step-by-step thing. And when I say step-by-step, I mean elementary step by elementary step. Okay, so if we're going to take a look at a chemical reaction, we must know its mechanism. Now, at this stage of the game, and even at my stage of the game, you don't know the mechanism. Those things have to be experimentally determined. Like you and I have no idea unless we research it or unless we read about it. Okay, so it's not that I'll ever ask you to just regurgitate some reaction mechanism for a reaction. That's not the way it works. But it helps us explain the rate of a reaction. Okay, so if we take a look at an analogy, a car is not built in one large step, but a sequence of smaller steps. So you've got a worker who controls the overall rate of production, will be our slowest worker. And he or she doesn't have to be the first person on the line or the last person on the line. It could be at any point on the line. It's just whoever is the slowest worker on that line is the one who determines the rate. Kind of like when you're running a race, okay? And say it's a relay race. Your team is affected most by the slowest member because that's who determines the rate, right? So adding workers at the fast steps won't affect how many cars you make. However, if you got a slow step, like a really intricate step that takes a lot of time, if you put your workers there, that should increase your rate of production. Okay, so we're going to call the slowest step in a chemical reaction our rate determining step. Okay, so when we look at example 1, here's a chemical reaction. So I've got my reactants on the left side, my products on the right side. And here's the thing. So you've got 4 molecules of hydrogen bromide and 1 molecule of oxygen gas. Realistically, very unlikely for 5 entities to collide in proper orientation with the appropriate amount of activation energy. Okay, so for our purposes, we know that it's not a one-step thing. Experimental evidence shows, and this is what I said to you before, you don't know this. You have to play around with it or you have to read about it. Somebody had to do some kind of experiment on the reaction mechanism. That increasing the concentration of oxygen increases your rate of reaction. So we can break down this overall reaction here into several steps, several elementary steps. And usually, like I said, they're collisions between 2 entities, not 5. All right. So when we look at our reaction mechanism, we have our elementary steps. We add those elementary steps up, kind of like Hess's law. Okay. And then you cancel out like terms on either side of the arrow to get your net or your target reaction, like we did with Hess's law. And that is the way a reaction mechanism works. So I'm going to scroll on up here. So remember, the reaction I showed you prior was 4 molecules of HBr and 1 molecule of oxygen gas, right? Well, look at the actual elementary steps that led to that. Okay, so you've got 3 elementary steps here. Okay, and you know that one of them is slow. And the reason they figured this out is because adding oxygen affected the rate of the reaction. And usually you're adding, the thing that affects the rate of reaction is usually affecting this slow step. This slow step is my rate determining step. That's supposed to be an ing. There we go. Okay, and so what ends up happening with a reaction mechanism is you've got your elementary steps here. We've got 3 of them. We've got one that's slower than the rest, so we call that our rate determining step. And then this is our net reaction right here. And what you end up doing is you end up canceling out like terms. So I have this intermediate product, okay, or reagent, and he cancels out there. I also have this intermediary canceling out there. And when I add up my HBr, HBr, and 2HBr, I get 4, right? And I've got my oxygen gas right here, okay? And my, oops, this should be a little plus sign, okay? And I've got my water, and I've got my bromine gas, and that's how it adds up. So just like Hess's law. So then, the first step is slow because it has a higher activation energy. So let's take a look at this. These are all my different steps, or this is the net result of those 3 elementary steps. So this guy is my rate determining step because it's got the highest activation energy, as you can see, the biggest hump. Okay, the overall rate is controlled by this large activation energy. If my system doesn't have this amount of kinetic energy, it will not go forward. Okay, the second step can't use the products of step 1, elementary step 1, until that product is made. So it really means that elementary step 1 is my rate determining step. Okay, now the guys that we canceled out, right, the HOBr and the HOOBr, they don't stick around. Those are my reaction intermediates that don't show up in the products because we cancel them out. Okay, these reaction intermediates are at my valleys, so meaning here and here. Okay, so those would be at the valleys. So this would be my HOOBr, and this one would be my HOBr. Okay, and my activated complexes, so don't forget those would be my transition states. Those would be like my HBr and my O and my O, and I know it's a double bond. It would be like the intermediate steps, these guys breaking and these guys making. Get what I'm saying? All right, so those would be my transition states. So a reaction intermediate is when you don't actually see it in the net or target equation. Okay? They're made but then quickly consumed. So then you're not going to see these guys. Okay, so you're not going to see it in the net equation or the overall reaction. All right, because they're canceled out. So example 2, if we take a look here, okay, if I look at my mechanism, so once again, there's 3 elementary steps. The first one is fast, the second one is slow, so this is my rate determining step right here, and this is my third one. So when we take a look and do the overall, N2O2 cancels out, and my N2O here cancels out. So those are my reaction intermediates. And now we'll add it up. Nothing else seems to be canceling out. No. Okay, so I'll end up with this plus 2H2 gas. All right, so NO plus NO equals 2NO. H2 plus H2 equals 2H2 now on this side. water, water. Right? So that's my overall reaction. And my rate determining step is elementary step 2. Because you know it's the slowest, right? A lot of times you can guess, but you never actually know unless you've got experimental evidence. So for our purposes, we'd always give you some kind of indication. Okay, and if we didn't give you an indication, we would say, which one do you think and why? And if your reasoning made sense, we'd give it to you. All right, so last situation, taking a look here, we've got, once again, 3 elementary steps. The third one is the slowest, so this is going to be my rate determining step. Okay, and we're going to cancel out like terms. So I've got 2 CLs there and a CL and a CL there. And I've got a singular hydrogen there and a singular hydrogen there. So those guys cancel out. Okay, so my overall reaction okay, and then on this side is 2 hydrogen chloride gases. All right, and once again, my rate determining step is sorry about that, is step 3. Okay, because it's the slowest. So once we take a look at that, that's all a reaction mechanism is. Lastly, and we can never forget this fun stuff, I urge you to read section 6.6 in your textbook and answer all of these awesome questions. You be good kids. If you have any issues, give us a shout. Take care. Don't give up. I want you guys to keep doing what you're doing. Everyone's doing a good job. Okay? Talk to you soon.